right, hello,
Hey,
Maya.
Maya, what do you call it?
No, we're not doing that. 5-3. Poison. This is called the Poisson distribution. It looks like poison, but it's with an extra S.
Yeah.
Kind of feels like poison a little bit too. Okay, but anyway, Poisson. Some dead guy with the last name of Poisson came up with this. Okay, Poisson distribution. I'm gonna talk to you how this like flows into this and like what we were doing before. So write this at the top of your paper. Binomial. The binomial distribution that we had up until this point had an N, a P, a Q, and an R, right? NPQR. I should have done NRPQ, but anyway, those four things is what we were looking for a binomial distribution, right? Facts. Okay, a Poisson distribution. Okay, a Poisson distribution will not have those elements to it. You are trying to find the probability in the same way, like it will be worded the same, but they will not give you the information for NPQR like you need. They will give you two things. They will give you an average, and they will give you like an X, or an R, I guess I should say. I'm going to call it R, because we're used to calling it R. So we have a mu and an R. Those are the only two pieces of information it will give to you, okay? Those two, and that's it. Sometimes, okay? Good? Ready? Okay, so here's the deal. With a binomial distribution, you have an N, you have a total. This is my total number, okay? This is like the upper limits.
Oh yeah, what did she say to you?
You have got to be quiet. Listen, write this at the top of the paper, okay? N is your upper limit, N is your total. Poisson does not have an upper limit. This is what the questions will look like. I'll zoom out, okay? Example, here's an example of a Poisson distribution. There, let's say, average of 3 tornadoes per year.
That's not very much.
The average of 3 tornadoes in Nebraska per year. I have no idea. Okay? Average of 3 tornadoes per year. Find the probability of 5 tornadoes.
What?
Okay? That's the only information it will give me. Shh. You gotta listen.
Awesome.
It's actually 55 tornadoes.
Okay?
Tell us
Whatever.
when we get done.
I'm making it smaller so that it's easier to do. Okay? We have an average of 3 tornadoes per year. I want to know the probability of having 5. 5 is more than average, right?
Yes.
But it still could happen, so it still has a probability or a chance of happening, okay? So in this case, our average or our mu is 3. The R is 5, okay? Now in this case, we don't have an upper limit. Like it doesn't say like 3 out of 10 tornadoes, right? Like it would say like 3 would be the R and 10 would be the N. We don't have an upper limit. The upper limit could be a maximum of 100,000 million tornadoes, right? We don't have an upper cap, okay? So that's the deal here. They're only going to give you 2 pieces of information. Now, they may do this to you. Real quick, write this down. They may instead say, let's say, I don't know. They may, instead of giving you mu, they might give you N and P. Okay? To start with, and then you use this information to find mu. Okay? So instead of giving you mu directly, they might give you N and P, and you have to find it. Okay? So just FYI. What?
You said this was going
It is going to go fast. All right. So here you go.
It's not going fast so far.
All right, Poisson distribution. Here's what they will do. An example of when this is applicable. Applications of this are number of internet users logging onto a website in one day, number of patients arriving to the emergency room, number of Atlantic hurricanes in 1 year, doing all of those things to help predict the number of hurricanes, the number of emergency room patients. Why would we want to know how many emergency room patients are predicted for any given day? Like how many people do we need to accommodate today? Is it going to be a rush today? Like those are things that are in the real world. We need to make predictions. So we use probabilities to predict those. Okay? All right, let's go down here. This is the formula for the Poisson distribution. We, instead of calling it X, we call it R usually. Okay? So switch those to R if you need to. Shh. Write those down. Switch those to R if you need to. Okay? In the formula, mu is here and mu is here.
What's negative mu?
It's negative mu. Negative mu. What's mu stand for?
Average.
The average or the
Is it just
mean.
the negative of whatever the average
In the
is?
middle.
You take it to the negative mu, whatever it is, right?
At the
Okay.
E to the negative mu.
Oh, mine's like very.
All right, next one, next variable, r. What's r stand for?
Hold on.
The number we want or the number that we're choosing. Shh, write this down. The number we want or the number that we're choosing. Yeah? The last thing that they have in here is e. We didn't talk about e above. What is e?
Just a number.
E is a number. Do you know what number e is?
2.71828.
2.71828818, whatever. Whatever. Okay? Your calculator has a button called E, and you just type that into your calculator. Everybody find on your calculator where the E button is. It might say E to the X power. Okay? And ln, you want the E one. Okay? E to the X or E, that's what you're looking for, okay? So other than that, you have two things. You have R and you have mu. That's all that you need. Okay? Good, good? Let's do a problem. Okay? By the way, the mean is mu. The standard deviation is the square root of mu. So if they ask you for standard deviation, you just take the square root of the mean. Okay, so circle those. If they ask for the standard deviation, you just take the square root of the average. That is like something that's different than what we've done before. So there you go. Okay? A particular Poisson distribution is determined only by the mean. We don't have a P and an R and an N and all that good stuff. And it has no upper limit because it has no N. No value for N. It has no value for N. It doesn't say like 3 out of 10 trees or 4 out of 16 students, right? We have no upper limit. We have no value of N. It could be as many hurricanes or as many tornadoes as we want it to be. Go to the back side. Let's do an example. Atlantic hurricanes. Here we go. Flip to the back. Flip to the back. Flip to the back. Okay? For the 55-year period. Okay? Circle the word 55 years. Since 1960. We don't care about 1960. 55-year period. There were 336 Atlantic hurricanes.
We care about that.
Okay, we care about that. So circle those two things. That's the information that they're giving me. There were 336 hurricanes in 55 years. Find the average number of hurricanes per year.
Divide.
So mu, I have to do a little bit of work there. They don't give it to me as P, but I take 336 and I divide by 55. How many hurricanes per year? 6.11. We'll go 2 decimal places. 6.11. Okay? That's how many hurricanes there were per year on average, okay? They want us to find the probability that there was actually 8 hurricanes in that year and not just 6, right? If on average there's 6, could there possibly be 8 in 1 year?
Yes.
Yeah, that's like not like crazy. If the average is 6, could there be 50 in 1 year?
No.
There could be, but it's probably going to be like a 0 plus, right? Like a very, very unlikely to happen, okay? So probability of 8 probably could happen. I'm going to do the work down here. Here's the formula for the Poisson distribution. P of x equals, it was mu. I don't have this memorized. Mu to the r times e to the negative mu over r factorial. There's my stuff, and we're going to plop stuff in. Okay? Here we go. There's the formula. What is mu? 6.11. What's r?
8.
To the 8th power. So 6.11 to the 8th power times e to the negative mu, which is negative 6.11. Okay? All over 8 factorial. Okay? It would not be a bad idea to put stuff in parentheses, especially that top part. Okay? If you're going to type it in all at one shot. Everybody practice typing this in. You will want to make sure you know how to type that in because it is kind of tricky to learn where the exponents and stuff are at, okay? If you have trouble, let me know.
Do we need to like put the whole number in there, just 6.11, or like all the with the extra stuff?
I would just do 6.11, it's fine. It should be, so probability, it should be a number less than 1. So if you're getting like 1 point or something, whatever.
0.
Oh man, I did that wrong.
70.
How do you put times 10 in there?
0.1070? Anybody get that?
0.0170.
E to the.
Okay, that's what you should get. If you don't get that,
Do you
let
use
me know.
carrot 3 or
Point.
carrot 8?
Carrots,
One.
yes. Yes.
0.
Comey, where's the E button at?
Perfect, man.
Ellen.
Guess what?
I am not getting.
That's so cool.
No.
I did already give you the exponent for it, so negative.
You're giving me a giant number.
Okay, did you get 0.1070?
No, mine is not. I don't know.
Yours is not.
No, I
Okay.
didn't.
Yours did not.
What'd you get?
They show me how to do it.
Okay, alright, so,
What is
good.
it?
That's the
The
last
articles
two.
of the-
Alright, we're gonna do a parenthesis.
I have like the
and we're going to
generic
do,
stuff,
what
but I
is
don't know how to put it into like
6.11.
two slides.
Is this what I'm supposed to
Or
get?
how-
that's what
or
6
how-
times.
Is this my answer?
6.11 to the
Cause I
eighth.
already have all the information.
I explain mine on one side and do
Times
examples on
The
the other.
easy thing about mine was
Is,
it's
right
yeah, thanks,
there.
so I could have a
So
slide for
second
each.
to the negative
How many slides do you have?
6.11.
Eight.
Close
I
parenthesis.
have my,
Divided by
my like
8.
explaining, my title, and then my conclusion, so,
Factorial.
done.
Oh, I didn't.
Where's my
divide by eight
factorial button?
factorial. Let me do that. Let me do that. Hold up.
Yeah, there you go.
Rob.
Take that number divided by 8 factorial.
Give it to me.
Mrs. Gobijar!
What?
Where's my factorial
Or-
button?
Let's go.
Did you get it?
No, where's my factorial button?
Let's go.
I don't know on that thing.
Is this it?
You don't know what a factor.
0.1069.
It is up there, Gray.
Oh, I didn't get that.
Yes, you did. Round up, Gray.
Oh.
You idiot.
Are you retarded?
My, crazy. What was the need for saying that?
Hey,
It's just a question. Yeah,
Don't
you're not
say
supposed to
that
say
word.
that word.
Yeah.
Well,
That's
no,
really
you act
rude.
like
Maybe you
one.
should take your cat upstairs.
I have to tell you right now. Okay, so the stupid cat was biting her
I already know this story.
once. No, you don't.
Bit her toe.
She, okay, so Chase was messing around with her, so she's like, oh,
Oh,
so
Adrian.
nobody else was having a problem with her, except my mother. So,
Actually,
Stand
Of course
up.
she was,
Tell her
because Jenny
stand up.
hates these.
Stand up.
I hate the thing.
Hey, she
I
goes,
like that.
take your cat upstairs now.
I
And I
don't wanna
literally
do
go,
the
I literally go,
Please.
yeah, I did. I took it, I'm like, she's fine. And I take it like back to me and she goes, no, take it upstairs. So I start walking up the stairs
And then she gets up and follows you.
and my mother gets up and follows me. We get upstairs and she goes, don't you ever talk to me like that. Stop talking so I can hear me. She goes, don't you ever talk to me like that in front of them, those people again. And I'm like, you don't talk to me like that. Like you, it's a two-way street, woman.
Okay, anyway. All right.
Stupid bathroom. And this morning, first thing she says to me, you can let Frankie out. Yeah.
Okay, anyway. Alright, did you get 0.1070? 0.1070. Shh. We can continue this later. Let's go. 0.1070. Yes?
Yeah.
What does that mean?
Well, 10%.
That's the event.
10.7% chance of what happening?
5 tornadoes.
Of having
8.
Oh, 8.
8 hurricanes
Oh,
My bad.
in a year. That's what that means. There is 10.7% chance of having 8 hurricanes in a year. We're still finding probability like we did with binomial, but they're giving us information that is not NPQR, so we have to use a different formula. Okay, but we're doing the same thing. Okay? All right, go down here. The main pick 4. Is this the last one? Hey, we're almost done. All right, main pick 4. Sometimes we don't know what mu is and we have to find it. So they'll give me N and they'll give me P, all right? In the main pick 4 game, you pay 50 cents to select your digits. And your digits are 0 through 9 and you get to pick 4 of them, like 1, 3, 7, 7, 9. Okay, now, here's the deal. Let's figure out.
Wait, you didn't. Did you do part C?
Was there a part C? Oh, was there a part C? Oh, sorry. Hey, okay. Moving on. Thank you, Emma. Because you have a question like this on your homework. In this, okay, hold on.
Retarded. It's not my fault.
We know.
Shut up.
Okay, in this 55-year period, there were actually 5 years that had 8 hurricanes.
Yeah, I did actually.
Okay, shh. In the 55-year period, there was actually 5 years that had 8 hurricanes. What percent is that? 5 out of 55 years. What percent is that had 8 hurricanes?
9.09%.
Okay, so 5 out of 55 years had 8 hurricanes. That is 9.09%, okay? We guesstimated that what percent would be 8 hurricanes? 10.7%. It
No,
says,
it's like pretty level.
that's the actual, right, but that was like we didn't know the actual, so that was the formula, what the formula told us for the probability. Does the Poisson distribution appear to be a good model?
Yeah.
Are those two numbers close to each other?
Yeah.
Yes. Yes. What is the cutoff mark?
Yeah.
I don't know, but they're good.
Two standard. No.
It is within how much percent?
5.
5%. That's the cutoff mark. So our number was 10.7%. That is within 5% of 9.09, right? Which was the actual. So the Poisson distribution did fit this model really good. Okay? Good. That was not bad. All right, because you'll have questions like that. All right, now here we go. In the main pick 4 game, you pay 50 cents. That means nothing. We don't care how much you pay. But you get to pick 4 digits that are 0 through 9. So like 1377, right? How many options are there? Like for me to pick if I have 4 digits?
A lot.
How many
9
digits could be?
times
No,
9.
no, 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 no. 0 through 9. That's 10 numbers. 10, 10, 10, 10, right?
F off, Rachel.
That is
10,000.
10,000. Okay? So what are my chances? What's the probability or the P of getting the winning one?
1 and 1, 10,000.
1 in 10,000. Do you see that? That's the probability of me winning. Okay? If you play this game once every day for a year, we need an N and a P. We already found P. What is N?
365.
365. I'm playing it 365 days. I'm playing it once a year, but for 365 days. So if they would have just said once today, my N would be 1. But 365 days. So on average, what's the chances of me winning? On average, how many times?
0, 365.
What? 0.0365? Okay, so
Wait, what?
what does this number represent?
How did we come up with that?
0.036. Oh. Let me write it out. How did we come up with that?
N times P.
N times P. So N is 365 times the chances of winning, which is P.
1 10,000.
Okay, now read me that number again.
0.0365.
365. Okay. Now that means the average number of times that I will win in a year is less than 1. I will not win. I will win less than once per year, right? Because my chances of winning there's 10,000 options, right? Okay. So
3%.
no, that's the average. That's not the P yet. Okay. So find the probability of winning at least once. Probability of winning at least once. At least one time. Okay, now every time we see at least once, we go, right? So, how many times total could I win out of the course of the year? I could win every single day, 365 days, right? Right? I could win 0 times. I could win 1 time. I could win 2 times. I could win 3 times. I could win 4 times. I could win all the way up through 365 times, yeah? At least once is all of these options,
So
right?
times 0.
So I want to find the probability of me not winning and then do what?
Subtract from.
Subtract from 100%. So I want to find the probability of 0 wins. Let's do that. Probability of 0 wins. All right, here's the formula. We do mu to the r times e to the negative mu over r factorial. All right. Probability of 0 wins. What's the average, or what's my mu?
0.0365
0.0365
times E
times what's to the r power?
0.
R power is 0.
Will we get a domain error if we put 0 on the bottom?
No, I'll show you why here in a second. Hold on. Times e to the negative 0.0365. Okay, before you start typing this in, I'm going to reduce it a lot because some of this stuff you don't have to type in.
1.
0 factorial. Okay, what's 0.0365 to the 0 power? 1. Don't type that in, right? Okay, what is 0 factorial?
Your mom.
1. It's
1. You're dividing by 1, right? So really, all we have to do is calculate this thing, right?
0.964.
0.964. Okay, that's the chances of me winning
So
0 times. I have a 96.
0.4.
I have a 96% chance that I'm going to win 0 times. So what's the chances of me winning at least once? 0.036. So 3.6% chance of winning at least 1 time, right? I have a 3.6% chance of winning at least 1 time.
How many of them do we have?
I want to know the
I don't know.
chances of me dying tomorrow if I've had 2 near-death experiences in my life.
You have to give me some numbers associated with that.
What?
Okay,
What are your new
all right, homework assignment.
I'm just hypothetical.
Hypothetical.
Yeah,
I don't
like
know.
what is that an actual thing? Like, can I predict
Your
my
chances
death?
are elevated more than the average person, yes.
So
probably.
what are my chances of dying tomorrow?
I don't know.
What are your new
I don't know. Okay,
Like, how many days have I lived?
there you go.
You never gave us any homework for this. Do we not have any?
Yeah, you do. 1 through 4, I think. I don't know. Maybe this is only front-sided. Hey, that would be nice. 1 through 4. All right. Bye, Maya.